On the next section, which is 7.7, we'll apply the quadratic, like the function or the polynomial, into some like the word problem, some other problems. So the factorization is when you see that the similar terms, well, like this. Well, actually not. Yeah, like that. When you see that some similar term, we combine them. So the factorization is when you see that some common terms were then we combine those terms and make somewhat like a simple or make change into the product of many different format. That is a factorization. So the most important thing is find the common factor. Or if that is like the greatest common factor, that's better. And factor out those and combine them. And sometimes we use like the factoring by group. So when you see the two terms together, put the two terms together and make like a one group, like ax plus ay. Then we see the a as a common factors and group them as a times x plus y. And then 6x plus 6y, we see the 6 as a common factor. And then group as a 6x plus y. Now we see the x plus y as a common factor. So group them together. Something like that. So, and one of the hard part of the factorization is when you see the three terms, like the trinomials. When you see the three terms, we can use many ways, and I showed you the two different ways, but there are many. You can choose your own, or you can find your own. But anyway, we have to do the factorization of this. We can use the following form, if you like. It is just depends on you. So for the x squared minus 2x minus 3, so here we do the like a cross, and the bottom is the product of this, or the constant negative 3, and this upper part is a coefficient of the negative 2, coefficient of x, which is a negative 2. Now we have to find the two numbers where the product is negative 3 and the sum is a negative 2. So we start from the product because the product, we only have really limited number of possible combinations for the product. So a equals negative 3, we only have two choices here. A equals negative 1, b is equal to 3, or a is 1 and b is a negative 3. Then we find the sum. The sum of this a plus b is a 2. The sum is a plus b is a negative 2. So we choose 1 and negative 3 as our pair. Then plug in plus 1 and negative 3. Then we got the factorization. Okay, so we use that in a somewhat like a much more general cases, which is a 4y squared. Instead of the coefficient as 1, we may have some other numbers. Then we still use the same thing, almost the same. Now on the bottom, instead of the constant 6, we use a product of 4 times the 6, which is a 24 here. And this negative 11 is the same as that negative 11 as before. Now we find the two numbers where the product is a 24 and the sum is negative 11. And we discussed that in here. Then we found that negative 3 and negative 8 satisfy those conditions. And then we divide by 4y. And the 4 is this number 4, and y is that y. So divided by 4y, which is a negative 3 over 4y and negative 8 over 4y, and simplify that as negative 3 over 4y and negative 2 over y. Then from the first term, we got a 4y minus 3. From the second term, we got a y minus 2. There are many ways, but this is one way. Anyway, you have to find your own way, or you can follow my way. Now, the next one is perfect square trinomial. So we have an x squared. This is a new, from now on, this is a new part. So we have x squared plus 2x plus y squared. When you do the factorization, we can use the very nice formula, which is x plus y squared, or x squared minus 2xy plus y squared is x minus y squared. Well, if you want to use the previous method, we can still use that as the following. So for example, if you want to use the previous method, which is x squared minus 2xy plus y squared, just imagine that y squared is just 1. So imagine this is x squared minus 2x plus 1. Just imagine that y is 1. Then what we can do is, we find the two numbers, cross it, and we find the number, which is a plus 1 is a product, and negative 2 is a sum. We now find the two number where the product is 1, positive 1, and the sum is a negative 2. That number is a negative 1 and negative 1. So negative 1 times negative 1 is a plus 1. Negative 1 plus negative 1 is negative 2. So that implies from this we get x minus 1. From this we get x minus 1. So this is x minus 1 squared. Now instead of just 1, we actually have y squared. So just replace with the y and y here. When you replace that, then we have 1y squared. So instead of 1, we actually have y squared. So just imagine 1 is y. So replace that, and we have x minus y squared. And that is a this one. And you want to remember this because without knowing this, you may have some trouble to do the factorization. So you want to know this. Anyway, let's apply this in here. So we have 16p squared minus 40p2 plus 25q squared. Now we're going to do the factorization. Yeah.
So you said remember this, you have to know for the factoring. That's x squared plus 2xy plus y squared. Is that only for what perfect square trinomials, or is that also for the polynomials and this formula?
Only the three terms trinomial.
Right.
When you see the three terms, x squared plus 2xy plus y squared, and when you want to make this into the factorization, something like the form, some product format.
Two parentheses.
Yeah, two parentheses.
Right, yeah, two sets of parentheses.
Yes, that's right.
Yeah.
So it looks like they are different, but when you change that into the following format, so let's let x is a 4p and y is a 5q. Then this is actually the 4p squared minus 2 times the 4p 5q plus 5q squared. So we can use the previous formula, which is 4p minus 5q squared. Then we are done. We finished the factorization. Any question?
So anytime there's perfect squares on the outside, the middle part pretty much doesn't matter?
Doesn't.
Okay.
So change into it. Maybe it is somewhat hard to find what is x and what is y. But if you practice, then you may figure it out. So when you have three terms, this is only for the three terms. When you have three terms, x squared plus 2xy plus y squared, then we can use the perfect square form. Any questions? Now, if you like, you can still use the previous method. So, in here we're gonna put the product of 16 and the 25. 16 times the 25 is 400. So this is a 400. And then this number is the same as this number, negative 40. Now we are going to choose the two numbers where the product is 400 and the sum is negative 40. What are they? Yeah, that is a really large, a lot of a combination. It is a negative 20 and negative 20. When you combine the negative 20 times negative 20, we get 400. When you add the negative 20 and negative 20, we get a negative 40. And we divide it by 16p. 16p. When you do that, we have a negative 20 over 16p, which is the same as negative 16 over 20p. So let's simplify this. Divide by 4, which makes the 5 and 4p. And that implies we have a 4p negative 5. But we have a q here, right? So you can put the q. So 4p minus 5q from the left hand side, and another 4p minus 5q from this side, which is a square. Any question?
What if you have a x squared plus 2xy minus y squared?
That's a good question, and we'll discuss that. So obviously the answer is we cannot use this formula. We have to develop some other things, right?
What? We just used it.
No. She asked the x squared plus
for that, yeah,
xy minus y squared.
Okay, cool.
Yeah. We cannot use that.
And because the minus y?
Yeah, because of the minus y squared. So what you can do about this? What do you think? Can you do something? The answer is no.
No.
There is no factorization for this. So we can do the grouping because we have x and x here, right? We can do the grouping. So we have x plus 2y, and then we have a negative y squared. Now, these two terms have no common part at all, right? So that's all. We cannot do it anymore.
Can't change the negative to a plus and then a minus y squared?
Then, yeah, if this is instead of negative, if this is a positive, then we can use those.
It'd be plus the negative y squared.
Yeah.
Yeah.
The way it works is also the following. So we can divide 2xy into just xy plus xy. So x squared plus xy plus xy plus y squared. We don't need to write down this. And the first two terms has a common factor as x. So plot x, and we have x times x plus y. The second two term has a y as common. So y and x plus y. Now x plus y is a common factor, so x plus y, x plus y. It is also possible, like this way. Any other question?
What happens to the xy on that last one? I mean, the outside, the outer x and the outer y.
So x plus y is a common factor.
Yeah,
So plot x plus y like that.
yeah.
Then what's left over? This x and plus y. So there is a x and plus y.
Okay.
Which is the same as x plus y in front. Now some useful formulas. X minus x squared minus, yeah, x squared minus y squared is x plus y times x minus y. X cubed plus y cubed is x plus y times x squared minus xy plus y squared. X cubed minus y cubed is x minus y times x squared plus xy plus y squared. So it is somewhat like easy to confuse about these two. So we have a plus y, then we need a plus, but suddenly we need negative here. When this is negative, we need negative, and then it has a plus. So they have different signs, plus and minus, for the cubic case, x cubed and y cubed case. Now let's apply this. So we have two terms. This is for the two terms, right? For the three terms, we use the formula, or we use such kind of like a cross and then find the number for the three terms, right? And this is only for the two terms case. Now let's do the factorization. We have 4m squared minus 9. So we may have to use one of these. So 4m squared is the same as 2m and quantity squared. And 9 is the same as 3 squared. So we have a something squared minus something squared, right? So we can use the first formula, which is 2m plus 3 and 2m minus 3. Any questions? Now let's do the following example. X squared minus 6x plus 9 minus y to the 4. So just imagine that we do not have this one first. So basically we only have three terms, x squared minus 6x plus 9. Can you do the factorization? We have three terms, right? So for the three terms, well, that is the two terms only. For the three terms, either we can use a formula for the three terms, which is a perfect square, or we can use this kind of method, right? Or we can use either one or the both. How about this? Three terms. What is the factorization? That's right, x minus 3 squared. So for these three terms, x squared minus 6x plus 9, we have x minus 3 squared. We use, where is that? We use this formula. X squared minus 2xy plus y squared. From x squared minus 2xy plus y squared is x minus y squared. Now let's think about the original one. Then the first three terms can be rewritten as x minus 3 squared. So we have x minus 3 squared minus y to the 4th. Just imagine that we have, instead of like three terms, we have only two terms. Something square minus something to the 4th power, but we never discussed the 4th power. We only have a square, right? Or the cubic. So instead of doing this, let's change the format as x minus 3 squared minus y squared in the square. Then finally we have something square minus something square, which is like x square minus y square. So we can use this. Something square minus something square is x plus y times x minus y. So we can use the first one plus the second one times the first one minus the second one. Because that is x plus y, x minus y. So that's it, which is x minus 3 plus y squared, and x minus 3 minus y squared. And that's the factorization. Any question? Okay, now let's discuss the next one. We have a n cubed minus 64 n cubed. So we have two terms. And then we have something cubed and something cubed also. So probably we have to use, this is a minus, so we have to use the third one, x cubed minus y cubed case. So let's write down the formula first. So we have x cubed minus y cubed is x minus y, x squared plus xy plus y squared. So we are convert the given one into something cubed minus something cubed. N cubed minus, we are going to change this into something cubed. What is that? 64?
4n.
That's right. 64 is a 4 cubed. So 4 times 4 times 4. So this is a 4n cubed. So we can use this, which is a n minus 4n, n, and n squared plus m times 4n plus 4n squared, which is m minus 4n, m squared. M 4n is the same as 4mn. 4n quantity square is a 16 n squared. So that's it. Any question?
How'd they get back to 16 square? How'd they get to 16?
Oh, so 4n squared is a 4n times a 4n. So 4 times 4 is a 16. 16 squared, n squared.
Oh,
Any other question? All right. That's all for this one. So let's move on to the next one.
That was 7.6.
Section 7.7. Quadratic equations and applications. The quadratic equation means an equation that can be written in the form of ax squared plus bx plus c is equal to 0, where a, b, c are constant or the real numbers, and the leading constant or the leading coefficient a is not equal to 0, is quoted as a quadratic equation. So ax squared plus bx plus c, when a is not equal to 0, is a quadratic equation. And this form is called the standard form. And the zero factor property, if AB, well, there is a multiplication obviously, A times B is equal to 0, then either A is a 0 or B is a 0 or the both. Well, it looks somewhat like confusion, but it looks really simple, right? But this is really important fact. So just the example is the following, which is simply 3 times 0 is a 0. We know that, right? 3 times 0 is a 0. Then either 3 is a 0 or 0 is a 0. This is a either. If one of this is a true, then that is a true. The first one is not true, obviously. 3 cannot be 0. But the second one is a true. Now 3 times x is equal to 0 implies either the same 3 is equal to 0 or x is equal to 0. I think we solved this kind of the thing, right? In the first example. So 3x is equal to 0 means we divide by 3, so we get x is equal to 0 over 3. So either one of these is a true. Well, for this case, x is a true. So there is a 0 factor property. When the product is a 0, at least one of them should be 0. It looks obvious and it looks simple, but it is really important. Now let's use this in the following example. Now we are solve 6x squared plus 7x is equal to 7. The solve means we are to find x value. Now find the x value. The first person will get a 1 point. Find x, which satisfies this. Anyone?
X is negative 3 over 2 and 1/3. It's 2 x's, right?
Yes. How are you gonna negative 3 have?
Calculator did it for me.
You use a calculator?
Yeah.
I cannot accept that.
It's okay. I wanted to know the answer.
Yeah, you have to use your hands and brain instead of calculator. So, yeah, the answers are correct. So let's look at that. So the first thing is, well, we are to change this into this format, ax squared plus bx plus c is equal to 0. Right. So we change this into 6x squared plus 7x minus 3 is equal to 0. This is step 1. The step 2 is, now we're gonna factor this. How can you do the factorization? You can use this method. The product, what is the product? What do we have to write down here?
Negative 3.
Negative 3?
Yeah.
But we have a 6 here. So we have to do 6 times the negative 3, which is negative 18. And then in here we have a sum as a 7. So we have to find the two numbers where the product AB is negative 18 and A plus B is the 7. We start from the product. AB. Well, it is possible that like the 1 and 18. If we have 1 and 18, well, either like a plus or a negative, we cannot get 7 as a sum, right? So instead of 1 and 18, what are the factors of other like the 18?
9 and negative 2.
9 and 2. So we get a 9 and 2 for the 18. The product is a negative means either one of these should be negative, but the other is positive. But the sum is a 7. That means this plus 9 and this is a negative 2. Then we get a product is negative 18. The sum is plus 7. So we have a 9 and we have a negative 2. Then we divide by 6x. We divide by 6x. And what happens is we have a 9 over 6x and negative 2 over 6x. Now we can simplify this as we have a 9 over 6x is divided by 3. We have a 3 over 2x. Negative 2 over 6x, we divide by 2. We get a negative 1 over 3x. So that implies from the first part we have a 2x plus 3. From the second part we have 3x minus 1. So this is a 2x plus 3. 3x minus 1 is equal to 0. Two x plus 3 times the 3x minus 1 is equal to 0 means, so A times B is equal to 0 means either A is a 0 or B is a 0, right? So either the 2x plus 3 is equal to 0 or 3x minus 1 is equal to 0. So that is 2x plus 3 is equal to 0 means move this 3 to the right hand side, which is a negative 3, and divide by 2. The next is equal to negative 3/2. And 3x minus 1 is equal to 0 means move this negative 1 to the right hand side and divide by 3. So we get x as 1/3. So these are the solutions.
Is there another way to figure out that the 2x should be plus 3?
Give me the other way to figure out this one, the factorization, or what?
Yeah, how did you know like the 2x was plus 3?
2x has a plus 3. So, well, as I said, this is one way. You can use that, or let's make another line. So you need to practice a lot. So you have to find your own way. That's the point. You have to find your own. It doesn't need to be my way. You can find your own way, or you can Google it. But that is one way. Or like the 6x squared plus the 7x minus 3. We want to do the factorization of this. So the way is, we know that if we can do, then we need two terms, right? And then obviously we need the x and x here on both sides. So we need x and we need x here. Up to that point, I think it is clear, right? Now we have to figure out the numbers here. We have 4 numbers. This 1, 2, 3, 4. We have 4 numbers. Now we have to figure out these 4 numbers. But the first 2 numbers, if I say A, B, C, D, if I combine these two, AC, what do I get? AX times CX. which is a 6x, should be the 6x squared. So a times c should be 6. And then when I multiply by the last term, b and d, I should get negative 3. So we have to figure out the numbers, the combination of the numbers. The product of AC is a 6, and the product of BD is a negative 3. But when you distribute this, we should have 7x also. The way is, I'll show you another method. So write down all the possible factors of 6 here, which is 1/6, or 6/1, or 2/3, or 3/2. And also write down all possible factors of negative 3, just a 3. We have a 1/3 and a 3/1. Now we do the cross product. The cross product is when you have the term here, we have to distribute to another term instead of within the term. That's the cross product. So when you do the cross product, we have to get a somewhat like near the 7, somewhat 7. So 1 times the 3. When you do 1/6 and the 3, 1/3, we get a 1. We have 1 times the 3, 3. 6 times 1, which is 6. So the sum is either 9 or 3 or negative 3. We cannot get 7. 6/1 and 1/3 the same. We cannot get a 6 times the 3 is 18. There is no way to get a plus 7. And 2/3 and the 1/3. 2/3 is 2 times the 3 is a 6, and 3 times 1 is a 3. So 6 and 3, there is no way to get a plus 7. And 3/2 and 1/3. Is it possible to get a 3/2 and a 1/3? So 3/2 and 1/3 is a 3 times the 3 is a 9. 2 times 1 is a 2. Now if this is a plus and this is a minus, then we can get plus 7. So to get a plus 9 we need a plus, and to get a negative 2 we need a negative 2. Then we have combination of a 3, 2, negative 1 and 3. So that is x and x. So this implies we have 3x minus 1, and this implies we have 2x plus 1. So we have 2 factors. And that is one way. There are so many ways, so basically you have to find your own way. If you think one of the methods looks better, then stick to that method and try to use that method to do the factorization. And if you practice over and over, I think that you can figure it out. Okay, I think that's all for this question. Any other question? Now let's move on. The square root property. Now if k is a non-negative, then the solution of x squared minus x squared is equal to k are the following. So x is, well, let me give you an example. So let's think about the following. X squared is a 4. What is x?
Two.
2. Is that 2?
2 squared equals
2 squared is 4. The 2 is a solution. We have only one solution. How about negative 2? Negative 2 times negative 2 is also 4, isn't it? So x is equal to plus minus 2. which is the same as x is equal to plus minus the radical of 4, or the square root of 4. Square root of 4 is a 2, right? So this x squared is equal to k implies x is equal to plus minus square root of k. And it is really easy to forget this negative. You answer that. Always, most of you answer that. You only answered the plus 2, right? You forgot the negative 2. Yep.
Why would you just not leave it at plus or minus 2? Why would you make it a radical?
The radical is, I want to explain the form. Does it make sense? Right? Because x, we know that when I solve this, we know that x is equal to plus minus 2, right? But in this, in a general case, it doesn't need to be a perfect square. It can be any like a 5, x squared equals 5, or x squared equals 6. Then we're gonna write down the solution, like the more general way.
Right.
So the 2, I want to show that the 2 is the same as radical 4.
Okay,
So
if that was
whenever
my
it
test and I wrote plus or minus 2.
Yeah, you have to write down as plus minus, obviously. So this implies that, right? But there is an intermediate step, but this implies that. Obviously, later on we have to go back to here as a final solution. But anyway, this is like intermediate step. X equals plus minus square root of 4. So when you see x squared is equal to k, then we always have to get x equals plus minus square root of k. Now we also x squared equals 18, then x equals plus minus square root of 18. Now we can simplify this as plus minus 18 is the same as 9 times 2. Now we can split square root of 9 and square root of 2, which is plus minus 3 square root of 2.
Hey,
So
in
this is a final answer.
the formula up there, the
Yep.
x squared equals k,
Mhm.
if it's always gonna be plus minus, why doesn't it have that in the formula? Plus minus k.
Like in here?
The square root property,
Yep.
and it shows, you circle in red, x squared equals k, and all the answers are x equals plus minus k. But
Plus
it's not-
minus square root of k.
Right, but if it's always gonna be plus minus, why isn't that written in the formula? So x squared equals plus minus k.
Because I am right now.
Wait, it's supposed to be the same as the formula, right? And all the answers have plus minus, but the formula don't.
Well,
All the answers gonna be plus or minus, and that,
always
But you-
plus minus.
but you don't put in the example formula?
Wait,
For mine?
you mean why I didn't, well, because I want to write down something.
Okay.
So that's the reason. Now for the x squared is equal to negative 3. What is x? Can you use this, the previous square root property? X squared equals negative 3. So is that a plus minus square root of negative 3? What is the condition?
Can't you not have the negative radical?
We said that k is a non-negative. Then this is a true. That implies when the k is negative, we cannot use that. We cannot. So this is not true at all.
Isn't it like plus or minus I square root 3?
That's right. This is an imaginary number. I know, but we don't discuss the imaginary number in this course. You can take the upper level, then you can use the square root of plus minus square root of 3i. Yeah, can use that. But don't worry about this course. You never see the I, imagine. So the answer is there is no solution. No. Because -3 is less than 0. Now we also x minus 4 and quantity square is 12. We can still use the same thing. Just imagine that x minus 4 is just one single number or the variable. Then something square is 12. Then we can use the formula. So x minus 4 is plus minus square root of the 12. So x minus 4 is just one single x. And plus minus square root of 12 is the same as 12 is 4 times 3, so plus minus 2 square root of 3. And what is x? Well, we want to get the x. To get the x, we have to move this minus 4. So move that, then we have 4 plus minus 2 times the square root of 3. So this is a solution.
So you don't have to worry about the square part at all at the very beginning? Like that?
No, we don't. But at the end, we have to simplify, always, as the simplest form.
So wait, how'd you get the equals 12 now plus or minus square root 3 or 2 square root?
So x minus 4 squared, we can imagine this as just x, the capital Y squared, well, like that. Just imagine this x minus 4 as just capital Y, the letter Y. So y squared is 12, right?
Yeah.
And y squared is 12 implies you can use this. So y is plus minus square root of 12, which is a plus minus square root of 12 is 4 times 3. So, which is a 2 square root of 3. So y, instead of y, we use x minus 4. So x minus 4 is plus minus 2 square root of 3. Finally, we are getting x value. So move this negative 4, which is this.
Is that your final answer, or do you?
Yep, this is the final answer.
So you don't need to do 6 root 3 and 2 root 3?
No.
Okay.
What do you mean the 2? We don't need 2? Well, what
You
is
can't, are you not supposed to add the 4 and the 2 and just keep the root?
Can you add the 2? Can you add the 4 and 2 radical 3? No, you cannot. You
Okay.
cannot add that. Because the 4 is a natural number or the integer, and the square root is irrational. You cannot add
Okay.
those two. Any other questions?
But that's true, right? I mean, a lot of times when you're doing radicals, that outside number gets changed, either multiplied or.
Yeah, that is only for the multiplication, not for the addition or subtractions. Now the quadratic formula. When you have a quadratic equation, ax squared plus bx plus c is equal to 0 when a is not equal to 0. Now we are going to find the x. Now, if it is possible, then we are going to apply the factorization. We are going to do the factorization first, and then we can find.
Sorry.
Yeah, we can find x and y. However, for sometimes we cannot do the factorization. Then we can use this very nice form, which is a quadratic form. That is really useful.
And it's a quadratic formula because it has 4
Because because of ax squared. Because we have x squared. X squared is a quadrant.
All right, the power of the x.
Yeah, the power.
And then what was a cube? Was
What do you mean?
a quadratic formula that has x squared. If it were x cubed, what would it call it?
Cubic. Now you can use a quadratic formula everywhere if you like. So even for this case, well, what is that? Yeah, even for this case, to solve this, we can use a quadratic formula to solve it. We'll apply that. Anyway, let's try to do the following example first. Let me add one more slide so we can actually apply that here. So we have a 6x squared plus 7x minus 3 is equal to 0. Now we're going to apply the quadratic formula. Negative b plus minus radical b squared minus 4ac over 2a. That is a quadratic formula. And here a is a 6, b is a 7, c is a negative 3. And if we apply that, x is equal to negative 7 plus minus square root 7 squared minus 4 times 6 times negative 3 over 2 times 6. So let's simplify the thingy. So this is a negative 7 plus minus square root. And 7 squared is a 49 minus 4 times 6 times a negative 3. 4 times 6 is a 24. So 24 times 3 is a 72. So we got a plus 72, which is 121, and which is 11 squared. This is 11 squared over 12. And then we can remove the square root and the square. So we have a negative 7 plus minus 11 over 12. Plus minus means we have two things. One is a negative 7 plus 11 case. The second case is negative 7, negative 11 case. Then this is a negative 7 plus 11 over 12 is 4 over 12. And this is a negative 18 over 12. 4 over 12 is 1 over 3. And we can divide it by 6. And we have negative 3 over 2. Now we got the solution for the previous one. So we can use a quadratic formula everywhere, even if we can do the factorization. Any question?
How did it go negative? Like, I don't know, you lost.
Was there which negative?
You got 7 plus 11 over 12, then you got negative 7.
This one?
Yeah.
From here to there?
Yeah.
So we have a plus minus. The plus minus means we have two different cases. The first one is plus case. So we have a negative 7 plus 11 case. And then the second one is a negative case, which is negative 7, negative 11 case. So negative 7 plus 11 is 4. So 4 over 12. Negative 7, negative 11 is negative 18.
But that's a positive 18 right there.
What did it say?
You said that's negative 18.
Yeah, negative 18 over 12.
Alright, I got you.
Yeah, yeah. And we can cancel. We can divide it by 4, which is 1/3. We can divide it by 6, which is a 3/2 negative. Any other question? use that. So let's do this and then take a break after that. So A is 1, B is -4, C is 2. Then x is equal to -4 plus minus square root -4 squared -4 AC and 2 times A, which is a 4 plus minus square root of 16 minus 8 over 2, which is a 4 plus minus square root of 8 over 2, 4 plus minus square root of 8 is a 2 square root of 2 over 2. And then we can split this in a 2 part. 4 plus 2 square root of 2 over 2 and 4 minus 2 square root of 2 over 2. And then the first one is, if we cancel the 2, this is a 2 plus square root of 2. And then if we cancel the 2, then this is a 2 minus square root of 2. So this is these two are the final solutions of that question. Any question? Okay.